Chameli Mitra, Assistant Professor, Swami Vivekananda Institute of Science and Technology. Today I will be discussing two-port network. This is a chapter of network theory which both electrical and electronic student faces. The chapter is a bit confusing while solving numericals, so I'll try to make it easy by making the concept easier through numericals, through solving numericals. So let's start the topic. Two-port network. Now first, what is a port? A port is basically a pair of nodes across which a device can be connected. So these are the nodes and this is the port across which a device can be connected. So there are different configurations of two-port network. There is one-port network and also two-port network. In case of one-port network, there is two nodes connected with a network, and in case of two-port network, there is four terminals connected with associated with this network. So basically, there are variables which are involved in a network. The basic variables are voltages and current. The voltage is measured across the pair of nodes and the current going into one node is the same as the current coming out of the other node. So these pairs of nodes are called entry and exit points of the network. So a network with two input terminals and two output terminals is called a four-terminal network or a two-port network. Next, there are several types of parameters associated with two-port network. That is open circuit impedance, short circuit impedance, transmission impedance, inverse transmission parameter, hybrid parameters and inverse hybrid parameters. Let's explore the first topic, that is open circuit impedance parameters. So in open circuit impedance parameters, called as Z parameters, we will learn why it is called open circuit parameters, why it is called impedance parameters. So I have already covered the point where I have said there are several variables associated with a network, that is voltages and currents. Now voltage and current, they will be dependent on each other. So if they have to depend on each other, they will can be represented as this, where V1, V2 are the voltages. The voltages over here at port 1 and at port 2, and the current I1 and I2 at port 1 and port 2. So these V1 and V2 are dependent on I1 and I2. Here I1 and I2 are the independent parameters and V1 and V2 are the dependent parameters. So if they have to depend on the voltages are dependent on current, then there will be some relation to it. So we can write this relation as V1 equals to some constant into I1, as V1 is dependent both on I1 and I2. Therefore we can write V1 equals to some constant into I1 plus some constant into I2. So similarly, we can write V2 some constant into I1 plus some constant into I2. Now this constant term is nothing but the Z parameters, Z11, Z12, Z21, Z22. Let's define this term. Z11 equals to, now if I have to find out Z11, we have to make I2 0 in this expression. If we have to find Z11, we have to make I2 0. Now if we make I2 0, this full part will be 0. So Z11 equals to V1 by I1. So Z11 equals to V1 by I1 at I2 equals to 0. So that is what is written over here, V1 by I1 at I2 equals to 0. The name of this parameter is driving point impedance at port 1. Now next parameter is Z12. Now how we will find Z12? Z12 equals to, in order to find Z12, we have to make I1 equals to 0 because Z11, Z12 are constant term, we cannot make it 0. We can only make the variable 0. So here we can make I1 equals to 0. So Z12 equals to V1 by I2 at I1 equals to 0. So V1 by I2 at I1 equals to 0. The name of this parameter is transfer impedance. Next, Z21. Z21 is again, if we refer this equation, Z21 equals to, we have to make I2 equals to 0, V2 by I1 and I2 equals to 0. So V2 by I1 and I2 equals to 0, transfer impedance, again this is called transfer impedance. Next, Z22, V2 by I2 at I1 equals to 0. Z22, we have to make I1 equals to 0, so V2 by I2 at I1 equals to 0. So we are getting V2 by I2 at I1 equals to 0. Name is driving point impedance at port 2. Now, if we notice the parameters, in all the cases, we have made I equals to 0, either at port 2 or at port 1. So when we are making I equals to 0, it means current 0 means open circuit, and hence the name open circuit impedance parameters. Why impedance? Because this is a ratio of voltage and current. Therefore, the name of the parameter is open circuit impedance parameters. Next, we will solve an example based on open circuit impedance parameter. So determine the Z parameters for this network. This network will be given. This type of example comes in, this type of sums comes in your semester exams. So if this is the circuit, we know for impedance parameters we need to make port 1 0, that is I1 0, and port 2, and also port 2 we have to make I2 0 in order to get the 4 parameters Z11, Z12, Z21 and Z2. So here also we will do the same thing. First we will make port 1 open circuit. Port 1 open circuit means we will have to make I1 equals to 0. I1 equals to 0. So if we make I1 equals to 0, then what will happen to the circuit? No current will flow through the 5 ohm resistor. So now if we solve this part, what we will get, if we apply KVL in the port 2, at the port 2, what we will get? 10 I2, the drop across this 10 ohm resistor will be 10 I2, then plus through this resistor, since I1 equals to 0, only I2 is flowing, so 20 I2, and the voltage over here is V2, but in the opposite direction. So if we take plus to minus as positive, so this will be negative, so minus V2 equals to 0. So now we are getting a relation between V2 and I2 at I1 equals to 0, which is nothing but Z22. So we got a value of Z22. Next we have to, since I1 equals to 0, next we at I1 equals to 0, at this condition we can find both two parameters, that is Z22 at I1 equals to 0, we find Z22 and also Z12. So next we will find Z12, that is a relation between V1 and I2. So if we have to find a relation between V1 and I2, then since the current flowing through this 5 ohm resistor is 0, we have to, the current flowing through 20 ohm resistor will be only I2. Therefore, we can write the V1 equals to 20 I2, since the current across current I1 equals to 0. Therefore, the current flowing through 20 ohm will be the drop at port 1, that is V1 equals to 20 I2. So Z12 equals to V1 by I2 and I1 equals to 0, we got the value of Z1. Next we will make port 2 open circuited. Now if we make port 2 open circuited means I2 equals to 0. So no current will flow through 10 ohm resistor. Now if we apply Kirchhoff's voltage law at port 1, what we will get is 5 I1 and plus 20 I1 plus I2, since I2 equals to 0, so 5 I1 plus 20 I1, and the direction of voltage is minus to plus, so minus V1 equals to 0. So Z1, so this, the relation between voltage and current at port 1 when we keep port I2 equals to 0 is nothing but Z1, and therefore we get the value of Z1. Next is, the only thing left is Z21. So to get Z21 we need a relation between V2 and I1 at I2 equals to 0. So V2 and I1, so since I2 equals to 0, so the drop across 10 ohm is 0. So through 20 ohm only I1 is flowing, so V2 equals to 20 I1. So from there we get the value of Z21 as 20. So this way we get the Z parameters of the network. And this is O, since all the values are obtained by the ratio of voltage and current. Next is short circuit admittance parameters or Y parameters. Now again the name short circuit and admittance parameters. So first of all, the variables are dependent on each other. Now current is a dependent variable and voltage is an independent variable. So since I1 is dependent on both V1 and V2, so we can write I1 equals to Y11 V1 plus Y12 V2 as like Z parameters. Similarly, I2 can be written as Y21 V1 plus Y22 V2. And the similar way as we have done Z parameters. Now we have to find Y11, Y12, Y21 and Y22. Now Y1, in order to find Y11 we have to keep V2 equals to 0. Then Y11 will be equals to I1 by V1 and V2 equals to 0. So the name of this is driving point admittance at port 1. Similarly for Y12 we will get I1 by V2 and V1 equals to 0. I1 by V2 and V1 equals to 0. If we make this part 0, then we will be left with Y1. So similarly the rest can be found. And why this is called admittance parameters? Because the ratio is I by V. That is current, the ratio between current and voltage. And why it is called short circuit? Because here for all the four we have made voltage equals to 0. So voltage equals to 0 means short circuit. Next we will try to solve this sum. Determine the Y parameters for the network. So here first we will make V1, port 1 short circuited. In the previous case we had open circuited, here we will short circuit. Now if we have to make short circuit, then the port 1 short circuited means the current always flows at in a low resistive path. So if this is short circuited means the current will not follow this 20 ohm resistor path. So this will be invalid, this path will be invalid. So the circuit becomes this. That is, the 20 ohm resistor is omitted when it is short circuited. When these two nodes are short circuited. So now we will apply KCL to get our required Y22 and Y12, which are the which will be found by making V1 equals to 0. So if we apply KCL, Kirchhoff's current law, at node 2, then V2 minus 0 divided by V2 minus 0 divided by 10 plus V2 minus 0 divided by 50 will be equals to I2. And in this way we will get a relation between I2 and V2 at V1 equals to 0. Next we need Y12 at this condition. So for Y12 we need a relation between I1 and V2. So I1 and V2, so 0 minus V2 divided by 50 equals to I1. 0 minus I1 equals to 0 minus 50, 0 minus V2 divided by 50, this is nothing but I1, 0 minus V2 divided by 50. So in this way we will get Y1. Now we will short circuit port 2. If we short circuit port 2, this was our sum, if we short circuit port 2, then the 10 ohm resistor will be of no use. So now if we redraw the circuit will be like this. Now if we apply KCL at node 1, we will get V1 minus 0 by 20, this V1 minus 0 by 50 equals to I1. So we will get Y11 by solving this, and I2 equals to 0 minus V1 divided by 50. 0 minus V1 divided by 50 will be nothing but I2. So in this way, by solving this, we will get Y21. So we get the Y parameters of the network and the unit respectively. Next is transmission parameters or ABCD parameters. So the transmission parameter matrix can be written as this, just like our Z parameters, Y parameters, these parameters are written like this. Now this V1 equals to A V2 minus B I2 and I1 equals to C V2 minus D I2. So let's define this. A equals to, A will be equals to V1 by V2 at I2 equals to 0. So this, the name of this is open circuit reverse voltage gain. Why voltage gain? Because this is a ratio of voltages. And why open circuit? Because I2, our current is made 0. Next is B. B will be equals to minus V1 by I2 and V2 equals to 0. B equals to, and V2 equals to 0, V1 by I2. So the name of the parameters is again short circuit because we have made voltage equals to 0, and this is a ratio of voltage and current, therefore transfer impedance. Similarly for C, we see at I2 equals to 0, therefore since current is 0, open circuit, and since it is a ratio of current and voltage, it is admittance. Next is D. D is short circuit, again current gain. So since voltage is 0, so short circuit, and the ratio of two currents at two poles, so this is the current gain. So let's solve one example. Determine the ABCD parameters of this network. So now in order to solve this type of network, what we will see is, here there is a pi. We need to convert this pi into star. So how we will convert this pi into star? So 2 into 2 divided by all the sum of the register is 2 plus 2 plus 2, that is 4 by 6 or 2 by 3. So all the values of all the registers in this pi is of 2 ohm. Therefore, the values over here all are same, 2 by 3, 2 by 3 and 2 by 3. Now if these two are in series, so we can add them and the complete network will be this 1.67 ohm, 1.67 ohm and 1.67. Now here first we will short circuit port 2. So V2 equals to 0. Now if we apply KVL, that is 1.67 I1 plus through 0.67, now I1 and I2 both will flow equals to V1. So we will get a relation between V1 and I1 I2, and again 0.61, again if we apply KVL in this loop, so 0.67 I1 plus I2 plus 1.67 I2 equals to 0. So again we will get a relation between I1 and I2. From there we will get D. Now if we put this value of I1 in here, we will get our B. So by short circuiting port 2 we are getting B and D. Next we will open circuit port 2. Now if we open circuit port 2, then this I2 will be 0, so no current will flow through this 1.67 ohm. Now V1 equals to 1.67 I1 plus 0.67 I1 since I2 equals to 0, and V2 will be equals to only 0.67 I1 because this part is, the I2 is 0, so I2 into 1.67 will be 0. So we will get C and A over here. C will be equals to I1 by V2. So basically from here we will get C. I1 by V2 is 1 by 0.67. And A will be equals to V1 by V2. Now V1 equals to 2.33 I1 and V2 equals to 0.67 I1. So if we divide V1 by V2, we will get 3.5. So these are, therefore we get the ABCD parameters of the network. Next is hybrid parameter, H parameter. So similarly the H parameter matrix can be written as this. V1 equals to H11 I1 plus H12 V2. So if we have to find out H11, we will have to make V2 0. So H11 equals to V1 by I1 at V2 equals to 0. H11 equals to V1 by I1 at V2 equals to 0. Again, since V2 equals to 0, this is short circuit, and since it is a ratio of voltage and current, this is impedance. So short circuit input impedance. Next, H12 is open circuit reverse voltage gain. Open circuit because I1 equals to 0 and voltage, since ratio of voltage, so voltage gain, and reverse because ratio of port 1 and port 2. Voltage at port 1, port 2 and not the reverse way. Like H12 is not V2 by V1 but V1 by V2. That's why it is written reverse voltage. And H21 equals to short circuit current gain because V2 equals to 0, so short circuit. And here since it is I2 by I1 and not I1 by I2, it is written short circuit current gain. Had it been I1 by I2, it would have been written short circuit reverse current gain. Next is H22 is I2 by V2 at I1 equals to 0. Therefore, open circuit output admittance. Next, this is the circuit determining the hybrid parameters of this network. So we have to apply KVL in this network. So 10 I1 plus 5 I1 plus I2, that is 15 I1 plus 5 I2 equals to V1 equals to V1. 10 I1 plus 5 I1 will be 15 I1 and 5 plus 5 I2 is 10 I1 plus 5 into I1 plus I2 equals to V1. So 15 I1 plus 5 I2 equals to V1. Next is the other loop. 15 I2 plus 5 I1 plus 15 I2 plus 5 I1 plus I2 equals to V2, that is 5 I1 plus 20 I2 equals to V2. Now the hybrid parameters are V1 equals to H11 I1 plus H12 V2 and I2 equals to H21 I1 plus H22 V2. So if we compare this with equation 2, what we will get is, if we divide equation 2 by 20, we will get I2 equals to minus 5 by 20 I1 plus V2 by 20. So this value of I2, if we put in equation 1, we will give 15 I1 plus 5. In place of I2, we will write the entire expression, minus 1 by 4 I1 plus 1 by 20 V2. That is equals to V1. Now we can compare this with our equation. V1 equals to H11 I1 plus H12 V2. So we will get these values respectively. H11 and H12. And from here I2 equals to minus 5 by 20, this is nothing but H21, that is minus 1 by 4, and H22 will be 1 by 20. 1 by 20. So we get our required H parameters.